let's welcome Michal Brygidyn, and Michal, stage is yours.
Hello, everyone. Thank you for joining this session. Today, I want to show you how to start testing security. Last year at this conference, I was talking to different people and asking why they are not into security. It's so fun. And the answer usually was how to start. We don't know how to start. We don't want to break something. But you know, security is everyone's job. So if you are building things, testing things, if you are running projects, you should have security knowledge to know what may happen if you don't follow best practices, if you don't test security. And about security, what it is, the security testing. Security can be defined with this CIA triad, so confidentiality, integrity, and availability. With confidentiality, we don't want our data to be available, to be accessible by people who are not allowed to. It should be private, it should be secured. With integrity, we want our data to stay the same as we put it there. We don't want anyone to tamper it. We don't want anyone to modify it. It's our data, and it should be in a way that we put it there, and our system processed it, and it stays that way. And then availability means that if we need that data, it's there for us. So the system works. We can log in. We can check what's there. We can check the bank account statement. We can check our archive in some messaging apps. So now we know what the security is, and what we need to know is what we want to test and what are our goals in security testing. First of all, we want to get the data, not ours data, someone else's data. And we want to find a way to extract this data, to access it, to see, to view, to check what's there behind the wall, behind this screen saying you don't have access. But hey, if I don't have access, someone else has access. So maybe there is a way to get there and see this. Then, if we already get access to the system, we can check if we can modify the data. Maybe there's a way to send a malicious request, and the data will be modified. We may not be able to see it, but it will be modified, and it is security vulnerability there. And then the last part, make the data unavailable. Try to drop the database. Don't be afraid of breaking things. This is part of security testing. If you are able to break something, then it means it wasn't designed in a way to prevent you from doing it. And if you are able to drop a database on a non-prod, do it. Because if you don't, then this system will be deployed to prod and someone else will do it. And then it will be a bit more expensive to fix. How to start? First of all, we have our projects. We work somewhere, we have our projects, so the easiest way is to start with our own projects, because we can access the source code, we can check what's there, and we can try to find a way to disrupt the process, to destroy something. If there is cloud infrastructure, maybe we are able to remove a part of this infrastructure. So it's a place where you can easily gain some experience in security testing. I will not be telling you how to check for SQL injection or DDoS, but these are the things that you should try in your projects. When you already know something that you found, for example, one vulnerability, there's a problem with our search bar, there's SQL injection, and if I put this phrase, something will be broken behind the scenes. If you have this, then, hey, this is the one system that has that, but maybe there are other systems, not ours, but some other systems that have the same vulnerability, because they were also developed by some developers who may follow the same bad practice. So there is a way to find more of them and find this leaking data behind it. Maybe there are some database dumps, etc. And we can try to find it, and explore other projects, not our project, but other projects, maybe play with some bug bounty programs. And the bug bounty programs are the last step here because we already have some experience. We know how to find things. We know how to identify vulnerability and find all instances of this vulnerability available on the internet. So we want to make money from it. There are bug bounties for that. How to start with own project, what to look for. Let's focus on the SDLC and not so secure SDLC. First thing, requirements. On the requirement stage, we can already see if the team thinks about security from the very beginning. First of all, privacy by design. If there is a template like that showing a lot of data on one screen, it means that someone can take a screenshot, someone maybe can present this and have a call with someone else, then share full screen, and the whole screen will be visible. So instead of putting things like that, we can mark it as a potential security issue and then change it to mask this data and only show a single row when needed. Then we have legal issues, like if you have PCI DSS compliance, you cannot store credit card data on disk, but hey, there are systems that are doing this. If you are in healthcare, you need to protect patients' data and some health things. I remember finding a database dump from a company from US. The company was renting expensive boats, and who rents expensive boats? Rich people, and the database contained their health information, what they can eat, what they cannot eat, etc. So this is kind of data that you need to protect. So if you know that your project will process this kind of data, you can already try to extract this data. Even if you are able to extract the test data, it means that on prod, you will be able to extract the prod data. Then it's good to have full stakeholder input. And this example shows that a stakeholder said, build us a chatbot, Gen AI chatbot. Everyone has one, so we need one as well. And they didn't tell the team what will be this chatbot doing. And then the team built it and trained it on the data provided by the stakeholders later. The data was a list of CVs, so I was able to talk to this chatbot and extract every single CV there, because there was no requirement to filter input or sanitize output. Then backups. If there are requirements to have backups, make sure that these backups are safe and stored in safe place, not the same server that is being backed, and not in public web root like here. Then design phase. First thing, architecture. You can already check if the system will be safe by looking at the architecture. If they are using old systems, old frameworks, just because they don't know anything newer, not because there are other requirements and the customer requires to use old system, but because the team doesn't know anything newer, better, more secure, then this may be already a problem. Then the thing that on all my presentations I want to tell that this principle of least privilege would prevent me from getting access to your systems. If you follow principle of least privilege, it means that your users or even developers, testers have access to part of project that they need access to. Users of your application have access to part of their application they will be using. And then nothing else. If you have, for example, a build server, Jenkins, and Jenkins is non-prod Jenkins, it builds on non-prod environment, don't make it admin on your prod environment just because maybe one day it will also build prod environment. Then design of functions. This is the example of a function to reset password, and this function sends email, and you can already see the password in plain text on this screen. You don't need to click that email to see the password. And when I got access to this inbox, I was just scrolling what's there, looking at addresses and topics, and hey, this looks looks like a password, and it was working password. And it was in the inbox of that user. So instead of that, maybe there will be a link. Click here and create your own password instead of providing it like that. Then APIs. Designing APIs can be tricky. This example shows partner portal from AWS partner program. And you can see that there's a list of some numbers, and numbers like 200 plus AWS certifications or 500 plus AWS customer launches. But it's 500 plus, not full number. But if you look at the requests to this API endpoint, you can extract raw data, and there will be a real number, and there will be more numbers that are not present here. So API gives that data. It's not used on front end, but it's there, and maybe it shouldn't be there. Maybe there's some sensitive data that was left there by mistake. Then we have error handling, and if the app throws an error and there is things like a plain text part with credentials to Office 365, because there is SMTP Office 365.com, then we already have a problem. If you see this, you can use it, you should use it, and log in there and submit a bug, a security bug. I have access to this inbox. And this slide shows the only public endpoints you should have in your projects. For prod environments, load balancers, CDNs, and API gateways. That's all. Not a database, not a server. These resources should be stored in private subnets with no public IPs. Because if it has a public IP and it's protected only by one firewall rule, it's not that protected, because if I get in and remove that rule or add another one letting me in, I'm in. If it was stored in private subnet, then it wouldn't be possible. And please remember that public clouds are public. So if you have access to public cloud by username and password or access key and secret key, then anyone with this information can access the public cloud. Then let's go to coding, best practices. As developers, you know best practices. As testers, you know best practices. What to do, what not to do. But there are some add-ons, some plugins to most popular IDEs that mark code that's, for example, too complex. Why too complex code may be a problem and a security problem? Because you can try some attacks looking at the time the application needs for a response. And if it's fast response, then probably the record doesn't exist. If it's longer response, maybe the record exists. That way you can iterate and iterate through, for example, users database and extract things from it that way. Then functionality. If developers think they need to design and build new authentication system, raise a red flag. It's never a good idea. These authentication systems should use frameworks that were tested by many other users and many other developers and testers. Do not reinvent the wheel, because there are so many things to fail, it will fail. Dependencies. This one is good. You can also look at what developers are building. If you're only focused on testing and not on building things, you can check what they are building, what are the puzzles developers use to build the application. And if one of the puzzles is, for example, a library from private repository, then do an exercise and create the same one in public repository with the same name, but higher version. And see if you build it next time, if it will get the lower version from private repository or higher version from public repository. If the one from public repository, the higher that you planted there, you have a security issue and a big one. Then the code flow, how developers work with the code. If they push everything to one branch straight to master, if you can push straight to master, if you can remove a part of a code, add part of a code, if they push credentials, plain text credentials to repository, things like that can be checked. And these are also problematic, because this can lead to non-trusted code being deployed somewhere later. Then we have logging, and if logs are created and stored somewhere, do you have access to these logs? If these logs are only for some errors, okay, but sometimes a lot more is logged, and developers are trying to log as much data as possible for troubleshooting something. Then they forget to remove this part, and then you have a full database row logged to the file every time someone opens a link. And other people have access to that, other developers have access to that, and this is a security issue. Then let's go to testing, and starting with automated tests. The most common case, we have tests, we have great coverage, and our tests are running in a pipeline. And they are muted because the pipeline wasn't going to the next phase because there were some issues, and we don't want to resolve them, so let's just mute automated tests, and hey, everything works. So if you see that there is a mute on tests, raise a red flag. Scope of tests. This is interesting when there were some cases when I found a lot of leaking data from a company. I reported it to them, and they told me, it's impossible, you just found it. You probably hacked us, and you are just telling us you found this. Why you are saying like that? It's here in public place. Oh, but we had a pen test last month, and it's impossible that it's there. But what was the scope of this pen test? The whole production. Haha, this is non-prod. Then access control. Try to get to places that you shouldn't have access to. If you are testing an app and there's admin panel, try to run a function that you know it exists because you are part of the project team, you know the code, and you know that there is a link that when admin clicks it, something is happening. So try to click that link, try to go to that directory, try to run an API behind that and see if it works, if it checks if you are admin or not. Then CI/CD pipeline. This is my favorite because usually when you have full automation, you have one resource that is admin on your cloud, for example. I work with clouds a lot, so this is my example for this. You have Jenkins, and Jenkins is full admin on your AWS account. Because Jenkins builds the infrastructure for you. Jenkins builds applications, images, and everything on your cloud, and on your non-prod and prod. So if you get access to Jenkins, you're admin there. But how you can get access to Jenkins? For example, you are admins, you have full admin rights on non-prod environment for testing, but you don't have admin rights on the production one. But Jenkins has full admin rights on both non-prod and prod. And you are admins on Jenkins, so you can create any job there. You can modify any pipeline. It means you can tell Jenkins to do whatever you want. And that way, you can push whatever you want, part of infrastructure to prod, and you're admin there. Someone blocked Jenkins? No problem. You don't need to modify it on the server itself. You can, for example, modify the code that builds the pipeline. And if you are able to push the change to the code, you can modify the pipeline. Or you can push a change to application code, and it will trigger a real pipeline on that automation server to build something on non-prod and prod. Try that. Do not be afraid of trying that. Then let's go to deployments. And first of all, if there is no automation for deployments, red or at least orange flag, because people make mistakes. Usually, when I find a security issue, the problem can be found between chair and the keyboard. And if you don't have automation, there are more problems. If you have automation, there are less problems. Infrastructure as code. If you work with cloud and you build things by clicking through the console, not by having it in the code, where's your single source of truth? How do you know if what's in the cloud should be there, if this is the configuration that you put there 2 years ago? If you don't have a definition in a code, you don't know that. So infrastructure as code not only helps developers or DevOps or whoever builds your cloud to build it, to maintain it, but it also is a source of truth. If someone like me, for example, getting access to your cloud account, modify something, and then the pipeline runs again, you will have drift, and it will be logged somewhere that there was a drift, there was a new firewall rule, and it will be reverted to what is defined in infrastructure as code. But if there is no infrastructure as code, there is no drift because it was changed and it's changed, and that's it. Then hardening. If you have some images, pipelines to build images in your projects, are these images hardened? Are the non-usable binaries removed and all other patched or not? If you are building servers, are these servers patched before putting to production or to any environment? Is the SSH blocked, or at least blocked login and password way of getting there? Let's say you have multiple environments. Only the production environment should be publicly accessible. There are VPNs, so it's easy to hide all other environments that don't make money for your customers, so don't make them lose money by publishing dev environments like that. And if there is a dev environment, it's usually pretty easy to get there to extract data and go to prod. Then, if you are using some tools, or the team is using some tools, make sure the team knows how these tools work. Not only how the tool should work for them, but what are the all functionalities of that tool. For example, this Jenkins that can be found in many places, publicly available with no authentication. If you go there, there's a thing like Jenkins credentials. If you're using Jenkins, you know that you can put some passwords there. But hey, it's a one-liner to get the plain text value of that. Then we have maintenance and regular patching. This is the easiest thing. You can analyze if if libraries in use are latest libraries, if there are any CVs on what you currently use in your project. Then you should have some kind of, or the team should have some kind of monitoring on, for example, logs. If you work with web apps, there should be monitoring and logging on error 500. If there is a rise in error 500, maybe someone is playing with your server. And last thing, do you have security audits, like external pen tests? If not, raise at least orange flag. Next step, we already know what to look for, how to find it. But now, let's find it. What we need data. Data is money, everything runs on data. So we want to find database dumps, we want to find credentials, we want to find some development tools exposed publicly, and we want to find different things that will give us more access. How to find it? For example, by a keyword. Nice example with Kubernetes. If there is a Kubernetes API publicly available, it will show you a JSON output, and just find a phrase from that JSON output and put it in Google in shotgun census binary, some search engines that scan the whole internet, and you will get all exposed Kubernetes clusters. And yeah, where? Google. Google is really nice for finding things with Google Docs. Bing, it's nice for finding things by IP. Then shotgun census and binary edge are the most evil search engines. They scan the whole internet, IP by IP, port by port, and they save the banner responses. So you don't need to make any noise in your target network. You already know that it's there, it's present. You just put one call to API or to that resource, and you have whatever you need. Starter kit, do not do it from your IP, because not everyone is aware how white hats work. So VPN is your friend, or some hotel Wi-Fi, neighbors Wi-Fi, whatever. Any web browser, no paid tools, nothing like that, and an idea. If you already know that there is a vulnerability, you have an idea. So now just use it. And the thing is, if you are testing security and you are focusing on one target, you can spend a lot of time finding vulnerabilities for that one target. And if you find it, nice, you will get a bounty, or you will get you can create an invoice for that assignment. But then, if you know that there is a vulnerability like that and it's available globally, you already have one vulnerability available in 100 places, And you can just send reports, 100 reports. Hey, I know you have a problem. I'm a good guy. I will help you. I'm not here to take your money, but if you have bug bounty program, vulnerability disclosure policy, whatever, I'm your guy. I can help you, and I already know that you have problem. And yeah, the research process is like that. Usually, you start with a manual play. You click through something, you found the problem. Nice, I have a problem here, and now I need to research it. I know that there is this Kubernetes cluster, but I can see this first JSON. But what's there? So then you do the research, and you can see that, okay, if I have access to Kubernetes cluster and Kubernetes API, I can check pods, I can check secrets, config maps, and then you have all you need to automate this. And instead of manually putting all these links, you can create a script that will check these links for you and analyze what's there. If you have that, then define the keywords that allowed you to find it in the first place. If you have the keyword, automate the whole thing. So the script will look for this leaking data. It will analyze it. It will create a report, and it will send you, sometimes even analyze the report, and send you an email, hey, you need to check these 4 files. There's money there. That way, you don't need to spend a lot of time, and you can still get a lot of money from it. Example research. Let's go to a random website and let's install a Shodan add-on. And Shodan add-on shows you things like IP of that website, open ports, etc. And let's start building an asset list. We already have one domain. That's our domain. We have one IP that is behind that domain. Sometimes this IP is not the real IP of the server. Sometimes it's the IP of some CDN or cloud server. It will give us nothing. But we have this IP. So we can go to Bing and check what's there on that IP, what other things are there. We can see that there are other things, and we can filter them out one by one, finding them. So by filtering them out, we can find another and another and another, and the asset list grows. So we have new domains, still not new, not another IP, but new domains. Then we can find other subdomains of the domains that we already found, and extend the asset list. That way, we have more targets for the same owner, the same company. Then we can use one of these search engines. This one is Binary Edge, and ask it, hey, give me all subdomains that you know of that domain. And then we find something like prev.testvares.pl. And let's go there. Hey, error 500. We found something. No idea what's there, but it doesn't look like a real production environment. And error 500 says that there is a server error. So you already have a problem, or you found a problem because you forced the server to report an error. And one by one, you cross out all these assets and gather all the information. And that way, you will find your way in. Sometimes unprotected endpoints, sometimes outdated things, things like that. And then you move from targeting a single system to targeting a single vulnerability. That way, you have this vulnerability. Find all instances of that vulnerability, get some bounty from that, move to another vulnerability, etc., etc., etc. Then go back to first vulnerability because for Kubernetes, it is like 100 new IPs every week. And then we have what we needed. We have everything in place. We have our findings. But we need to report these findings. So let's create a nice report saying that, hey, I am, my name, my last name, I'm not anonymous, I'm certified, I know what I am doing, and I identified a problem in your system, and I am reporting it to you. I have no idea if you have some policies for that. I'm sending this to DPO, Data Protection Officer, or security at the company, or any other email that can be found on the website, sending the initial message, hey, you have a problem, I found it. When I started doing this, I was sending these emails to people responsible for the problem, so to developers, to testers who made a mistake publishing something. This was not a good outcome for me because they were not paying, and this was not a good outcome for the company because the company never knew that there was a problem. They just fixed it and forgot. So instead of that, I am sending this to data protection officers, to CISO, to C-levels that I find on LinkedIn. And then you already know how to look for this data, you know how to report it, but you want more, you already like it, and you're into security testing. So how to get more targets and more money? Bug bounty programs. The most popular one, HackerOne, just sign up there and you will see, first of all, you will see Hacktivity. So the board with all interesting findings. You can filter them by, for example, the biggest bounty or by latest. And as you can see, there are interesting logos there. I found things in US Department of Defense or some big banks, and I reported it there. They paid nice, and it was all clear. Then I just created invoice for the HackerOne. Everything was smooth because there is policy for that, so you know what you can do, what you shouldn't be doing. Then we have another one, Bugcrowd, and with Bugcrowd, the same thing as HackerOne. You have other companies that use Bugcrowd as their vulnerability disclosure policy handler or the bug bounty program. Different companies there. Sign up for all of them and you will see different companies in different places. Sometimes company doesn't want to be found, so they are not on the list. They are using HackerOne, but you cannot find it until they invite you. They will invite you randomly if you have good standings with other companies, you found nice things, or they will invite you after you send them email with your findings to DPO, and he will say, okay, we have a program, we will invite you now. Then integrity, another one. Yeah, usually it's like looking for people, for people who I should contact on LinkedIn. I'm looking for chief, for CEO, CTO, CISO, so the top level people in the organization. Why? Because they will do something. Even if they don't understand what I am saying, they will have people that will understand and that will want to act immediately because our CEO just sent us this. What else to learn? If you want to play with security testing, Burp Suite is the one tool that you will use a lot because it can replay your requests, it can change your requests, it can record requests. You go to a website, you browse the website, it records every step, and then you can try to repeat it. You can try to repeat it with different variables. It's a useful one. Then we have Pacu. It's a small tool to analyze AWS. If I find access and secret key, I don't want to go there and then click through everything and check what API endpoints are available for me. I just run Pacu and it gives me everything. I already know what I can do with these credentials. Then Git secret scanners. This is something you can do right now with your projects. Scan the repository and check if your developers made a mistake by pushing credentials, plain text passwords, configs with some connection strings with login and password. If you can find it in current revision, then hey, big red flag. If in older revision, then check if these credentials are still valid. Sometimes a developer makes a mistake, pushes a key, but then he realizes, oops, that's a problem. I will push a new version with some dummy value. But the most important part was missed. Rotating the key, changing the password. Git remembers. So you can ask Git, hey, do you remember any interesting stuff there? And it will tell you, these are the passwords, these are the keys. And if you find it, big red flag. And then you don't want to do all of this manually. So instead of doing it manually, write a script. Write a script to do something for you. You can use Selenium to click through something. You can use Bash or Python. Bash and Python, or right now Python is my my favorite. I can write it. And if any tools, like hacking-related tools in Python, they work smoothly, and chat can help with something that I don't know. Let's say a new SDK for a new thing that I want to hack. I don't know it, but chat will help. It will create a one similar to the previous one that you developed yourself. And yeah, automation ideas. I have this whole architecture that finds and analyzes things for me. It starts by running a query against the showdown, for example. Hey, give me all Kubernetes clusters. And then I have these IPs. The IPs go to S3 bucket on AWS as a TXT file. There's a new file. OK, there's a Lambda that grabs the file, and each IP from the file is a new message in the queue. Then each message in a queue triggers another Lambda that grabs the message, that's the IP. It goes there, analyzes what's there, creates a report, and we have our report stored on S3. Then, if everything is done and the queue is empty, there's another Lambda that analyzes this report and send me an email. You should look at this and that. So you will one day, if you like security testing, and you will be doing things like this. You will want to automate things, because then you will waste way less time on clicking and doing things that can be automated. And that was the last slide. Thank you.
So we have couple of minutes for questions. Do you have any questions for Michal?
Thanks for the presentation. Regarding the Git security scanners, do you have anything specific to recommend?
If you Google Git security scan,
I was just Googling.
Yeah, you will get many of them. I don't know any names, so I cannot tell you any names, but there are many scripts already there. You can just run them and ask them, hey, give me all AWS credentials there. Give me all strings that are complex enough to be a password.
Okay.
So I will not give you a name of one, because there are many that will do the same thing, and you can test them all.
All right, thank you.
Just be sure if you run something on your code, it's a real tool and not a malicious one that will send your code somewhere else.
Okay, thanks. And who else? Any more questions for Michal? Okay.
Hello, thanks for the presentation. I was wondering how AI stands in this area. Are there any tools, or what's the current state of it?
Current state, I don't know any tools out of the box that will do this, but AI helps a lot in analyzing things. So when I store my reports on S3 bucket, I can run AI on that bucket to analyze what's there. And the biggest problem is identifying the owner. Because if you are on the assignment as a pen tester, you know your boss. You know that if you find something in this asset, that's the owner. But if you find an asset with a problem, who's the owner of that? You need to go in, you need to analyze what's there, find an email address, find a domain, anything like that. So this is where AI helps a lot, because it speeds up things. If there is a report with a lot of data, AI can just process all these files, and you can ask, okay, what domains are found in this? Well, these are the domains that can be found in linking together these reports and something like that. So I don't know any out-of-the-box tool, and it's getting harder to make ChatGPT provide you with some useful scripts. You really need to think how to escape all these boundaries of chat, saying that you are just training people and you really need this. Or there is one hack that I found on chat. If you provide part of the code saying that you just want it to extend with some functions, it will help you. But if you say, build something for me, it will tell you nope. But this O1 preview has the reasoning behind also available. So there is there was this output saying, I cannot provide answer directly, but I am able to modify the code that was provided. So just provide hello world and ask it to modify it.
Okay, thanks. Thanks. Yep.
Hi, as part of what you are doing is, let's call it unordered security audit.
Yep.
So how to stay out of the trouble?
Always wear a white hat. So do not try to break things, do not try to delete things. If you get access to a server and you know the owner, stop it. Just stop it, report it, send a report saying, this is my name, I found it, this is my IP that I used, and you have a problem there. In Poland, if I do that and it's not a government server, it's all fine because I was doing it in a goodwill. In UK, the same law, you are doing it in a goodwill. In US, they are aware of it, and in US it's even easier because all government departments were forced like 2 years ago to have a vulnerability disclosure policy. So if you find something in US, usually they know that you are the good one because you are reporting it to them and not using this against them. So I only had one problem with a company from UK once when I found scans of passports and I reported it to them, sending one of the scans to them. Hey, this is my proof. So I never do that again. They told me that this was identity theft. But when I asked the London police if it was a problem, after sending them the whole conversation, they said nope, but the company haven't reported it to the ICO, so they will have a problem now.
Okay, so we have time for 1 or 2 questions. Anyone?
If you have more questions, I'm available on LinkedIn, so just catch me there.
Okay, so thank you, Michal, again. Big
Thank you.
applause. Yeah.